Hello, third year. This video is going to look at something called standard deviation. Okay, now so far what we've done is we've looked at the range as a way of looking at our data and seeing how kind of spread out it is. We've also looked at interquartile range, and that looks at the middle 50% of the data and sees how spread out that is. So that tends to be where the concentrated data is, and that excludes what we would call outliers. Okay, so things that lie at the very beginning of a set of data or values that are at the other end, so maybe the smallest and the largest. It excludes those and focuses on the middle set of data. There is a measure called standard deviation that is more accurate. It's one of the best ways to measure the spread of data. Okay, now we can go into this in more detail later, but what we really want to do with this video is just focus on the calculation. I want you to know how to calculate standard deviation, and it's quite a mechanical process. Okay, it's just a process that you need to learn. In a minute, I'm going to show you the formula for standard deviation. It looks like a horrible formula. Okay, I'm going to tell you that now. However, the good news is you get this in your formula sheet in your exam. So there is no need at all for you to memorize this formula. You do need to remember how to use it. That's the important thing. So here it goes. The standard deviation we write as, I'm happy for you to use SD. And the standard deviation is x minus x bar squared all over n minus 1, and we take, I'm not very happy with that square root. We take the square root of all of that. Now you're probably looking at that going, there's lots of things in there I just don't understand, and that's okay. Alright, so here we go. This is the symbol sigma, and it means sum of, okay? So in other words, it means we're going to add up a number of values, okay? X is a data value from our range of data. X bar, you'll be pleased to know, is just the mean, and you've met the mean before, so that's not new. And N is the sample size, in other words, the number of bits of data that you have. And again, you've met that before. So really the new things that you've met today are the sum of, and that's it really. Nothing else is new. This idea of sum of is new. Now the way we take care of this sum of situation is we use a table method, okay? And we're going to use a table that's going to take care of this entire top row. It's going to produce a value for our top row, and then once we have that, the rest is fairly straightforward, okay? So we're going to walk through this step by step. Now, here is our data set here, and you can see that that's already in numerical order, which is great. So first things first, this is the kind of easy bit. Our first column in our table is just going to be these data values, and literally all we're going to do is copy those across. So we've got 3, 6, 7, 7, we have an 8, a 9, another 9, a 10, an 11, a 12, a 13, and a 15. Now with questions like this, you really need to concentrate and focus, okay? Because most of the mistakes are going to be made because you've not been paying attention, all right? Because there's lots of numbers. If you miss a number out or anything like that, it's going to throw off your answer. So that's where the majority of the mistakes are made with these questions, okay? The next line, we're going to do x minus x bar, okay? I actually think I put an extra column in this table that I don't even need. Before we can do x minus x bar, that's this bit inside the bracket, yeah, we need to work out the mean. Remember, x bar is just the mean. So x bar, I'm going to write in brackets the mean. And you don't need to write that obviously for yourselves, but just as a reminder, is we have to add up 3 plus 6 plus 7 plus 7 plus 8 plus 9 plus 9 plus 10 plus 11 plus 12 plus 13 plus 25. Now I happen to know that's 120. And there's also how many bits of data there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Excuse me. 12 bits of data there. So 120 divided by 12 is 10. All right. So I'm saying that my mean is 10. Okay. So this column of our table, we're going to take each of these values and we're going to subtract the mean. Okay. So we're going to take each of those values all the way down and we're going to subtract 10 from each one. So 3 subtract 10, negative 7. 6 subtract 10, negative 4. 7 subtract 10 is negative 3. 7 subtract 10, negative 3. 8 subtract 10, negative 2. 9 subtract 10, negative 1. Another negative 1. 10 subtract 10 will be 0. 11 subtract 10, 1, 2, 3, and finally 5. Now, what you can see there, your eagle-eyed observation, you can see as we progress down here that we go from the largest negative number all the way to the largest positive number, and we're passing through 0. If you've arranged your data into numerical order, that is the trend that you should see. That list should go from negative, quite a large negative, all the way down to the largest positive. Okay, so it's worth organizing your data because that kind of helps to let you see that you're on the right track. Okay, now the next stage of this formula, x minus x bar squared, that's what we're going to do in our column now. So we're going to do x minus x bar squared. In other words, we're going to take all the answers in here and we're going to square them. Now, this is important, please remember it. When you are completing this, you should not get, in this column, there should never be a negative answer ever, okay? Because when you square a negative number, you always get a positive answer. Why is that? Well, let's just take an example. Negative 4 squared is the same as negative 4 multiplied by negative 4. You know that when you multiply two negative numbers together, you get a positive number. So in that column, x minus x bar squared, you should never, ever get a negative number. If you're using your calculator to help you with this, which you might need to do if you've got bigger numbers or decimal numbers, anything like that, that's absolutely fine. But please make sure when you do the calculator bit that you use brackets. So I literally want you to put into your calculator something like bracket negative 4, then press your squared button, and then you will get your answer of 16. If you do not put your brackets in and you just type in negative 4 squared, the calculator is going to punch out negative 16. You should not get a negative answer. Now, I'm labouring that point, and I know I'm labouring that point, but so many people make that mistake, so let's not have it happen here. So negative 7 squared, 49, then we get 16, 9, 9, 4, 1 squared is 1, 0 squared is 0, then we've got 1, then we've got 4, we've got 9, and then we've got 25. Okay, that's my x minus x bar squared column. Now, the last bit of this is where we do the sum of, yep, I'm just going to move that across actually. So we do the sum of x minus x bar squared. In other words, guys, what we're going to do is we're going to total up this column here. Okay, because that is the x minus x bar squared. We found that for all of these values all the way down. Okay, all we're going to do now is we are going to total up that column, and that is going to give us our answer. So that's a bit of a big line. Let's just trim that slightly, shall we? So x minus x bar squared is that column added up. Okay, absolutely fine to use your calculator here. I'm going to, so that's 9, 4, 1, 1, 0, 1, 4, 9, and 25. I get 128 there. Oh, that's, yeah, 128. We're just going to do a double check on that, make sure we're happy. So 49 plus 16 plus 9 plus 9 plus 4 plus 1 plus 1 plus 1 plus 4 plus 9 plus 25. Yeah, 128. So x minus x bar squared, the sum of that entire top line, look at that, same as the formula, is going to be equal to 128. Okay. Oops. Oh, take that away. So I'm going to write my formula down here now. I might need a little bit more room, so let's just scooch that example down a little bit. That's for another video, so don't worry, we're not going to be doing that in this one. Okay, here we go. So standard deviation equals the sum of x minus x bar squared all over n minus 1, and then we take the square root of that. Now remember, we've just done that whole table to take care of this whole top line. So this line becomes the 128 straight from our table. Okay, so this becomes 128. Remember that n is the sample size, the number of bits of data. Well, we've got 12 bits of data, so n minus 1 is going to be 11. So again, this is a calculator situation, okay? You don't need to do all this in your head. So two ways of doing it. You either do your square root and you use your fraction button. So you do 128 over 11. That's one option. Okay. Or the alternative is that you do the square root and you open a bracket and do 128 divided by 11. And that should get you the answer of 3.411. And lots of numbers after that. Rounded, let's go with 3.4. Alright, so the standard deviation for this set of data is 3.4. Okay, and we're working in age, so we can assume that that's 3.4 years. Okay, that's how we calculate standard deviation. Alright, now I would strongly suggest that you use this video carefully as you work through your first sheet, just like last week. The first part of this work is calculating standard deviation. Okay, so please work your way through that. What I would also ask you to do before you try any of the examples, make sure that you get the same numbers as me as you work through this. Okay, particularly down here, make sure that you are getting the 3.4 there. Okay, you need to be able to use your calculator properly with this, otherwise things start to go awry. Alright, this is a fairly simple example because they're nice round numbers, deliberately chosen to make it a bit easier. Okay, but if you look at the question that we're going to tackle down here, we've got decimal numbers and all that kind of stuff. So make sure that you can get this value, this answer here on your own calculator. If you're having problems with that, please get in touch with me. It's really not a problem. Okay, take your time, work through the video step by step, watch it as many times as you need. Remember, you can also access this example through your class notebook. Okay, the next phase, the next video is going to look at analysis of standard deviation. But for now, all we're going to do is focus on the calculation. So a table to help you find the top line, the sum of x minus x bar squared, and then the calculation is fairly easy after that. Okay, any questions, get in touch. This is new stuff, but it does come up in the National 5 exam all the time, and it tends to be a larger mark question. Okay, so it's well worth getting to grips with this because actually it's fairly easy marks to pick up in your exam. So let's not let that opportunity pass us by. Okay, good luck. Be in touch if you need help. It's no problem.